All right. Well, good afternoon, everybody. Good morning, wherever you may be. I want to look at today logarithmic functions. So, for a moment, I want you to consider the following. Convert between logarithmic where's my C? L-O Anyway, let me put this somewhere else. Convert between logarithmic and exponential forms. That's what we're going to talk about. So consider the following equations in which the variable is located in the exponent of an expression. In these cases, the solution can be found by inspection. So let's say we have 5 to the x equals 5. Five to the x equals 25. And 5 to the x equals 125. So in these three cases here, it doesn't take a lot to identify what the answer is, only by inspection. So you can only have one answer. But in these cases only, you can identify it very quickly, because you know that x in this case would only have to be 1. Because 5 to the 1 is 5. And in this case, x would equal 2. And here, 3. Because 5 cubed is 125. All right, so let's go over a definition. All right. Definition. If x and b are positive, real numbers, such that b cannot equal 1, then y equals log base b of x is the logarithmic function. So we have an equivalent relationship. So y equals log base b of x is equivalent to b of y, b to the exponent of y, which equals x. So let's look at some examples. So in this case, we're going to write each equation in an exponential form. So log of base 2 is 16 equals 4. Let's start with this one. So I want to convert it to its exponential form. So I'm going to need to use this definition up here. So I need to use this whole relationship. I need to use that. So notice in the log y equals log base b of x, the base now in the new form is b to the y equals x. So let's identify b in this case. So in this particular problem, b is 2. So we're going to write 2 to the 4th, so 2 to this power equals 16. And it's true because you could see that 2 times itself 4 times will give you 16. Now suppose we had a problem like this. Log, and in this case it's a base 7, 1 equals 0. So we're just writing it in exponential form. So we're going to write 7 to the 0 equals 1. And we know that to be true because anything to the 0 power is 1. Now for a slightly more complicated question, log base 10 of 1 over 100 equals -2. So I'm rewriting that over again. It looks difficult, but all you're going to do is write 10 to the power of -2 equals 1 over 100. And we know that to be true because 10 to the -2 is 1 over 10 squared, which is 1 over 100. So now let's have the exponential form and convert it to logarithmic form. So we'll write 3 to the 4th equals 81. 3 to the 4th is 81. And I want to write it in logarithmic form. It was given to me in exponential form. So I'll start out, and I know what my base is. That's my base. So here's my log. Base 3 of 81 equals 4. What about this one? 1/5 to the minus 1 equals 5. So my base in this case is going to be 1/5. So log 1/5 of 5 equals minus 1. Okay. All right. So that's just converting between exponential and log and exponential. And you're basically writing the same thing over and over again in different forms. Now, suppose we had to do something like evaluate a logarithmic. Suppose we had to evaluate a logarithmic expression. All right. So let's start with log of base 4 equal to 16. So if we want to evaluate this, we want to let y represent the value of the logarithm. So I'm going to set that log 4 of 16. I'm sorry, I wrote this incorrectly here. So log 4 of 16, set it equal to y. So you're letting the log equal a variable, and it could be any variable that you want. In this case, I let it be y. So log 4 of 16 is the exponent to which 4 must be raised to equal 16. So what are we saying? That is 4 to some power equals 16. So we already know the answer to this, that y has to be equal to 2. So really, I could write 4 to the y is 16. So we can tell that y equals 2 by inspection. And you can check it. 4 squared is 16, so 16 equals 16. All right, so let's look at some more. Log base is 1/2 of 8. You want to evaluate that. So once again, we're going to have our variable. Log 1/2 8 equals y. So how are we going to write this? We're going to write 1/2 to the y equals 8. So take a minute and think about that. Pause the video and see if you can figure out what your y is. So one particular thing that you can do when you have these fractions is to think of how to write both things on the same side. So if I put 1/2 y to the y power I want the same thing on this side. So I have 1/2 here. And remember, I want to get 8. So I'm going to write -3 here. So I write the same thing in both parens and try to figure out how I can get 8. Now, what's my logic behind this? So 1/2 to the -3 is going to be equal to, and we've talked about this before, change the power, make it positive, and find the reciprocal of the inside. So the reciprocal of 1/2 is 2/1, or just 2, which gives me 8. So this we've covered earlier on in the semester, but you can see how using some fancy logic you can work your way around and find the answer. So now let's look at evaluating common and natural logarithms. Evaluating common and natural logarithms. So a natural logarithm, I'll get to that in a moment, but it has a different notation for it. So let's look at a problem. So log of 100,000. All right. So you want to evaluate that. So we're going to do the same thing we did before. Log 100,000 equals y. Now, when we don't have any base, we're going to write it first in the exponential form. So I'm going to write 10 to the y equals 100,000. So you know what y has to be, 5. Or equivalently, you could write 10 to the y equals 10 to the 5th, because 10 to the 5th equals this. So 10 to the 5th over here, then I know y is equal to 5. Let's look at another one. So log of 0.001. Log of 0.001. First thing, to begin, I'll put solution here. So I'm going to write log 0.001, and this is a log of 0.01 equals y. Once again, 10 to the y equals 0.01. Or you can equivalent write it as 10 to the y equals 10 to the minus 3. So y equals minus 3. All right, what about natural logs? So natural logs have a symbol with ln. That's our symbol for natural log. Okay? So natural log, the problem is natural log of e to the fourth equals y. Now here's something that you want to know. You want to do something called exponentiate both sides. So you want to exponentiate both sides. What that means is multiply both sides by e. All right? Multiply both sides by e. So if we multiply the left side by an exponential function, e, we'll end up with e to the fourth. If I multiply the right side by e, I end up with e to the y. So you can see what y is. Y is equal to 4. Let's look at another one. So natural log of 1 over e. So the solution will be to take this side, natural log 1 over e, and set it equal to y. So now you have two sides. If I exponentiate the left side, I end up with 1 over e. If I exponentiate this side, I get e to the y. Now, very easily you can see that 1 over e is the same thing as e to the minus 1, which equals e to the y. So y equals minus 1. And that's it. So let's summarize some of the properties, basic properties that we have here. So 1, zero, since b to the 0 equals 1. 2, log of base b of b equals 1 because b to the 1 equals b. b to the x equals x because b to the x equals b to the x. Four, and I'm going to give you an examples for these. So b log base b of x equals x. Since this, and number 4 is important because this is a base to an exponent that is a log. So log, since log of base b of x equals it's b of x. So keep these in mind, 1, 2, 3, and 4. So for examples, for number 1, we have log 5 of 1 equals 0, since 5 to the 0 equals 1. Base b, base of 3 equals 1, because, and you know, 3 to the 1 equals 3. And the third one, log base 2 of 2 to the x equals x, since 2 to the x equals 2 to the x. And the fourth one, 7 that's a 7, and that's an x is equal to x, because log 7 of x equals log 7 of x. So if you're asking yourself, it looks like we're just writing the same thing over and over again. We are, in a sense, we are actually writing from logarithmic form to exponential form in back and forth. Okay, now so that's going to be the end for this section on logarithms. This was our introduction of them. Okay, next we're going to look at applying some properties of logarithms and how to solve logarithmic equations.